In this video, we'll be going over a few techniques that you can use to make your setups a little bit more readable. Now, whenever you're designing a setup, it's important to consider how someone else is going to read it. This is because oftentimes someone else is going to need to pick up your setup, oftentimes late at night. And if your setup is really hard to read, then it's going to take you longer to explain it, and it'll take it longer for them to understand it and be able to eventually use it to create an effect with. In my opinion, the first and most important thing that you should consider when trying to make your setups readable is simply the positioning of the nodes in your setup. So if I'm trying to pick up a HIP file and I see that the nodes are organized something like this, no one can read this. Someone picking up this HIP file is going to have to either spend a lot of time, especially if it's a really complicated setup, they'll have to spend a lot of time reorganizing the nodes so that they can actually read the setup, or they're going to have to just ditch the setup and rebuild it themselves from scratch. Or maybe even just steal little components from it that maybe aren't quite as badly organized as this. Now, you might be thinking this is kind of an extreme example, and you're kind of right, but you'd be surprised. But let's just look at an example that might actually come up very often. So even if I have something that's kind of like this, I can even move this node over here, where the second input is on the left and the first input is on the right. If I'm zoomed way out here like this, to me this looks like this is the first input and this is the second input. Even if I select the nodes and make it green, it's still not clear which one's going into which input. And so in order to tell what's wired into what, I actually have to zoom all the way in. And even because of the way that the colors are, I actually have to select the pop net to make them green to even tell very clearly which one's going into which input. Things like this can add a lot of time to reading your setup, more than you might think, because if someone gets these things confused and then goes off somewhere else in your setup, they might spend a lot of time trying to figure out why this is the source and how it actually creates something that's a source, and then they have to come back here and then realize that they got the inputs mixed up. It might sound like a simple thing, but just organizing your setup where nodes are placed in positions that people might expect goes a long way towards making your setup readable. So if the nodes are organized something like this, or even like how I had them originally before I started messing with it, if I zoom way out, I can see that this node is actually wired into the first input, and this node is wired into the second input. And you can even see that by selecting them, when the wires turn green, it's actually pretty clear which is going where. And since this is a pop net, and since people generally wire sources into the first input, I can even tell that this is the source of the pop net without even having to dive inside the pop net, most likely. The other thing that you can do with positioning is you can use positioning to show where logical sections in your setup are. So if we identify logical sections in this very simple setup, you might say, well, here's a node that makes a grid and it makes our collision surface. And so that's kind of a logical section of the setup, so we can move that over there. And then this grid node and this point node create sort of another logical section because they're creating our source together. So we can move those off by themselves. And then our pop net can just sit here by itself because it contains a bunch of nodes inside of it that kind of constitute another logical section of the setup. I'll just move this guy up here. This kind of sectioning is probably the most important thing to consider when thinking about where to place your nodes in the setup. And the reason for that is if you imagine between just reading an enormous block of text and reading text with sentences and paragraphs, it's kind of like the difference between those two things. So with this, I know that there's sort of a topic in the setup. This is one topic, or one paragraph, and this is one paragraph, and this is one paragraph. So I know that I can start and stop inside this section and get an idea of something important about the setup. And same thing over here, I can just look at this one node and I'll know something important about the setup. I don't necessarily know what that important thing is used for, but I will when I read the rest of the setup. And this type of reading makes it a lot easier and a lot faster for people to pick up your setups, rather than if all of your nodes are stuck together in one big jumble and it's hard to tell where things start and stop. It's like reading a whole bunch of run-on sentences with no periods, and there's a bunch of ands, and you never really know what the point of any given word in the sentence is. Now you might have noticed that there's an unneeded node in this setup, and I keep moving it around with the rest of the nodes, and that would be this attrib create node. We don't actually need this attrib create node in this setup, it's just kind of hanging off the side. I used it previously for demonstration purposes, and indeed it actually did something that was very important to the setup at one time, but it's really not needed. Now, there are a couple of different ways I can deal with a node like this. I would say that 90% of the time, the best thing to do with this node is to simply delete it. Clean setups don't have a ton of nodes hanging off the tree. It makes things confusing, and unfortunately the nature of Houdini is that you can have a string of nodes that goes off to the side, and then that string of nodes can actually be used by an expression somewhere. So if you have nodes that are just hanging off the tree and not being used, it really makes you think, oh, this is there to be used, and then you realize that it's not actually there to be used. However, sometimes for demonstration purposes, or because you think you might need to use this node sometime in the future, instead of the node that you're actually using now, you might want to keep this node around. And in that case, we can move on to the next topic, which is coloring nodes. So coloring nodes is a very important concept, and it's key to making setups readable. So in this case, we have a node here, and we need a way to tell the people reading our setup that we're not actually using it. So what we need to do is we need to create what's called a convention. A convention is simply a set of practices that you use and you never really deviate from. So in this case, I might say that I always make nodes that I'm not using in my setup black. So what you do to color a node is you select the node, and then you hit the C key, C for color, and it brings up this little palette down here, and you can give the node a whole bunch of different colors. So since I'm not going to be using this node, at least not right away, I can color it black. And then I can press the C key to get rid of the palette again, so I don't accidentally click it and color nodes that I don't mean to. Now, when I'm reading this setup, this node is just off to the side, it's colored black. Someone can probably tell that this is not part of the actual setup currently. Especially if, by convention, I make black nodes that I'm not actually using, but still have to keep around for whatever reason. So if we stick to our conventions, this can make our setups a lot easier to read. Another thing that we can do with to denote containers of other nodes. So for instance, this popnet contains other nodes, so maybe we can color it green. So if you select it and hit the C key again, we can just color it green. So the advantage to this, especially in a very large setup, is that if you zoom out, this allows people to tell at a glance what's going on in your setup. You can tell that here's a node that's not even being used, here's a node that contains other nodes, so it's probably important, especially since it's sitting there by itself. We can use the positioning of the nodes to tell generally where the sections of the setup are. And generally things are pretty clear. But there's something else that we could do to make it even more clear. So if we zoom back in here, this is another very important thing that you can do to make your setup not a mess for someone to pick up. And that is naming your nodes. So I'm not really a stickler for you have to name every single node in your setup. Like, if you have this node, it's a grid node, it's pretty clear what it does. It makes a grid. If it's doing something that is unusual for this type of node, then it can be a great idea to name it. But I think that we don't have to name these nodes. So what I'm a big proponent of is naming all of the key nodes in your setup. So you need to identify which nodes are actually key. And in this setup, we have this point stop here that adds velocity, and that ends up driving where the particles go. So this is a very important node in the setup, and someone just looking at that just sees 0.1, and they have no idea what this is doing. So what we can do is we can just call it something like add velocity to control particles. Now, if someone's reading this, if they're zoomed in enough to be able to read that label, and they're wondering what this node does, they immediately know that it's adding velocity, and we're going to use that to control the particles. And they can look down here, and they see this the first input of the popnet, and since all the nodes are placed properly, they can tell immediately that this is being used to control the velocities on the source, which is probably used for the initial velocities of the particles. Now, if I named this grid something, like initial grid or something like that, I'm not really sure how this contributes to the readability of the setup, and that's why I say identify key nodes. The other thing to consider when thinking about this concept of key nodes is that effects setups are generally over 10,000 nodes. If you're going to name every single node in your setup, it's going to cost you a lot of extra time. But if you only name all the key nodes, you have almost the same readability, if not the exact same readability, and you're saving a lot of time by not naming a bunch of nodes that you don't need to. So in the spirit of naming key nodes, let's just go ahead and name our popnet here. I'll just call it something like fireworks particles. And now you might be thinking that this node, I said before that it's pretty clear what it is, and that's true, it's pretty clear that it's making a grid, but it's not exactly clear what it's used for. And in fact, in order to tell what this grid node is used for, I have to actually go inside the popnet, and then it's still pretty hard to tell because I have to select each node and find which node is actually referencing the second input. And it's even on the wrong folder, and so I have to go over here and say, oh, it's using second context geometry, and so that means that it must be using that grid. So it's actually really hard to tell what this grid is actually doing, even if we know what it's producing. Now we could just name it something like collision grid, and that's not a bad option, but I'd like to introduce you to another technique, which is using nulls to name parts of your setup. If we're thinking of sections of nodes in our setup as sentences, so then these two nodes constitute one sentence, then you might think of a null at the end of it as like the period of the sentence. But really what it is, it's another node at the very end that sort of says this is what everything preceding me is doing. And that can be really helpful. So let's just go to create a null node now. So null, I'm just going to click in here to drop it in. And now I'm just going to name it source out. And if you remember what we talked about with coloring nodes, nulls are a great node to color. Because, especially if you're using them this way, because if we color this node, let's say hitting the C key to get the palette up, let's say we color it dark blue or something. Then if we zoom out, we know to look at the blue nodes to see sort of what the big picture is, or what's going on in the section preceding it. Another great way to use these nulls when you're reading a setup is if you see this and you're trying to figure out what's going on in this popnet, then even aside from looking at the fact that it's the first input here, you can tell because it tells you exactly what's going into it. This is the source, this null is telling you. So I don't even have to look at any of these nodes. If I just move them up here, I know that the source is coming in here from something. And since the null tells me what's going on, I don't even have to read the rest of this setup in order to know what's happening here. And maybe that'll be good enough for my purposes while I'm reading it. Maybe I don't need to know what this stuff is. Whereas I would need to know what it was if not for the null. So I just pull this back down. And this is great over here because we have this node here that is just creating a grid. And having a null here, if I just create a null, put it down, hit the C key to bring up the color palette, color it blue, we can call it collisions out. Now that we have this node here, it's a lot easier to tell what's going on. Even if we do the thing where we move the nodes that actually do things away from the setup and we zoom in, from the nulls, we can at a glance tell what's happening with this popnet without even having to go inside the popnet and read the pops. And that's great because if you are constantly diving into and out of nodes in a setup, it adds a lot of extra time and it can make it confusing for someone who's reading it because then they have to remember everything that's happening inside this other node. Whereas if you've organized your setup well and made it so that they can read it easily, they don't necessarily have to do that. Now eventually they will have to dive into this popnet and see the details of what's going on, but they already have an idea of what to expect in there just by looking at your nulls. Alright, I'm just going to organize this setup back the way it was. And we can move on to the next thing. Now one thing you might be wondering is, why am I capitalizing the names of the nulls? And the reason nulls is simply to make them stand out. And it even makes them stand out here. So they're colored differently, and they're also capitalized, so it makes it really easy to see them. But then if you're looking at the node picker window, it'll actually put these capitalized nodes in a different place. They'll be at the top. So then if you're trying to find this node because you want to use the same source for some other particles or maybe for a dynamics sim, then it makes it really easy to spot right away simply because it's capitalized. So I prefer to capitalize nulls always, just by convention. So the last thing that we should discuss is network boxes. And network boxes are just another way of creating logical sections in your setup. So in this case I've already kind of split out my setup by logical sections, but if I had a network that was, again, tens or hundreds of thousands of nodes, and it was this really complicated, messy tree that was all the way out here, it still might be kind of hard to see where the sections are, even though I've placed my nodes pretty well. So in that case, SideEffects has given us network boxes that we can use to very visually separate parts of our setup. The way that you create these is you select a bunch of nodes that go into a box. So let's just select these guys maybe, because they're all part of one thing. And then you can either hit this button up here, which creates a box, or you can just hit Control N with all of them selected. Either way, it does the same thing. Now, with network boxes, just like with nodes, you can color them. So if you select it, and then hit the C key again, we can still pick colors and make them different colors. I like to make them the darkest colors that I can. And then hit the C key to get rid of it again. And then the other thing that you'll notice is this place up here where it says netbox1. So if you notice, I can actually click into that and select it, and I can type another name. So maybe we should name this. So maybe like create source. So now if I zoom out, even if I'm zoomed way out, I can see a box there, so I know that's one section. So it's just another easy way to sort of segregate your code. So let's just go ahead and create a network box for the other major section in our setup, which is the collisions. So we can select these. I'm just going to hit Control N to bring that up. And then select it, hit the C key, maybe color it yellow. And then call it collisions. So I don't really have a convention for coloring network boxes because they can kind of go around anything. So I usually just color them each one a different color if I can, so that when you're zoomed out it's easy to see which network box starts where. But if you can figure out a convention for this that makes sense, then more power to you. And really, with all of this stuff, it's going to end up just being your own experience as to which techniques you use where. You might be thinking that all of these different things are overkill for a setup this simple, and you would be right about that. I'm trying to teach techniques and principles using a simplified setup. In many situations, you might not want to use all of these techniques all at once, like this. It might actually make it harder to read if you have a bunch of nulls getting in the way, or you have a bunch of network boxes and a bunch of network boxes inside of network boxes, and suddenly it's over organized and someone's reading and getting really confused. So for example, if I had something like this. This is much harder to read. Less is more. So really, as you practice with this and as you try to figure out what works for you, you may decide just not to use some of these techniques, or you might decide that you might find situations where some techniques are more applicable than others. And obviously this is by no means a comprehensive list of all the techniques that you can use to make ups. Really, the best advice I can give you is when you pick up setups from other people, take a look at what they did and try to identify things that make it easier for you to read their setup, and then try to copy what they're doing. And then also, on the other side of that, if you find things in their setup to make it harder for you to read, try to identify what those things are exactly, and then don't do what they do.